rocket experiences an impulse from the engine, and that changes the momentum of the rocket. And let's turn to tomatoes. I want tomatoes because I want a complete inelastic collision. If one tomato hits the floor, the change of momentum is mv, if m is the mass of the tomato. But I'm going to throw n on the floor, so the change of momentum is n as in Nancy times the mass of the tomato times v. And this is the number of kilograms per second of tomatoes that I throw on the floor. So this equals delta p divided by delta t. And that's an average force. So the floor, and I can write it down in a somewhat more civilized form, F equals the mdt times the velocity, if the velocity of the tomatoes that hit the floor is constant. And this is then the number of kilograms per second that I throw on the floor. Here's the rocket. And the rocket is spewing out gas with a velocity u, which is fixed relative to the rocket. It's a burning of chemical energy. Chemicals are burned, it comes out with a certain speed, and the rocket will then experience a force, which we call the thrust, and that is given by this equation. If we take the case of the Saturn rockets that were used for the landing on the moon. For the Saturn rockets, the speed u was about 2.5 kilometers per second. So the gas came out with 2.5 kilometers per second relative to the rocket. And the rate at which this gas was coming out is phenomenal. 15 tons of material per second. The mdt is about 15,000 kilograms per second. It's almost unimaginable. And that would give it then a thrust of about 35 million newtons. Which of course was higher than the weight of the rocket. Otherwise the rocket would never go up.